Okay, all right, great. So good evening, everyone. You're welcome to another section of the KodeCamp. So let me start by sharing my screen and put it up. All right. So you're welcome to another day. So this is day 4 in our sessions. Okay, so this is day 4 in our sessions, and let me share my screen. All right, so we'll be having a continuation of object-oriented programming. Okay, we'll be having a continuation of object-oriented programming. Last week, or rather last class, I keep on looking at this last week. It's been a while. Last class, Tuesday, we looked at object-oriented programming, and we tried to describe what it is. Okay, so we try to describe what object-oriented programming is. We looked at the key concepts of what an object is, and we described an object as just the same way you have an entity in a real world. You realize that the entity has, for starters, you could put it in simple terms like a name. You could have attributes, and then you could also have actions. So we looked at names as things like describing what the object is. And for example, I give an example of talking about my coffee mug. So that could be the name, so the noun. Then we looked at attributes. Okay, attributes or properties of the object, and this could be descriptors. They could be things that the object has. So for example, we looked at things like color, we looked at things like size, and we realized that attributes are more like name and value pairs. You have more of like a key and a value pair. So you have, for example, maybe color, and then the value of the color. So for color black, color is be the key, and then you have the value. And then we looked at things like the methods that each object does. Okay, so we looked at it as functions. What does this object do? So this is more of an action. So objects also have actions. And then when we looked at looking at classes and objects, we realized that there's some similarity between the definition of them, because both of them have names, both of them have attributes, and both of them have methods. So what exactly was the difference between them? And we tried to describe the difference between an object and a class, saying that the class is basically the code templates that brings about an object. So the class is not necessarily like something that will be how do I describe it now? We said that a class is more or less like the code template, like the mold. I give a description of if you're making bread, it would be the pan that gives it the shape, that gives it the form, that gives it what it does. And then, so we looked at the object now as being what is made out of that class. So you could have one class producing, multiple objects. And then from there, we started about, the idea of the pillars of object-oriented programming. So we looked at abstraction, and we also looked at encapsulation. So much of what we did is available on our YouTube handle. So just go to YouTube, type in KodeCamp with a K, type in KodeCamp and search for NodeJS intermediate class, and you will see the classes that we've had. So if you haven't caught up on the class first to our third classes, please go back to YouTube, watch the videos, try to internalize the concepts. We'll try to break it down to you. So today we'll be continuing with introduction to object-oriented programming. Once again, my name is Benjamin Ifinudu. I'm a software developer. I'm specialized with the main stack, so MongoDB, Express, React, and also Node.js, and I'm also specialized with the .NET full stack. So you can reach me at AOSoft on the Slack handle on the KodeCamp workspace. I'm not alone on this. I also have Prosper Rauke here, and he is a backend developer. He's specialized with Node.js, MongoDB, Express.js, TypeScript, and you can also reach him on our Slack workspace at prosper.js. So we'll be going into the business of today. So I would start today's class from where we stopped last class. In our last class, we were looking at the concept of inheritance, and I realized that the concept is pretty much something that you need to understand to move to the final concept. Okay, so from looking at abstraction, we realized that when we went into encapsulation, we still had to use some level of understanding of what we got from abstraction to relate with encapsulation. Now we are in inheritance, and we realize that the other two concepts are still going to be greatly in use here. So generally, those concepts work together. Okay, these concepts work together because they are somehow intertwined. So I will have to explain inheritance again, and then from there break it down and then move into polymorphism. So let's look at inheritance. Now we said inheritance allows. Let me get this up. Okay, spotlight. Okay, yeah. So we said inheritance allows a newly created class to acquire the attributes and methods of an existing class. So that existing class is the parent, while the newly created class that is acquiring the attributes and methods of that class is the child. So here we have an example here, and we have here, this is a person class. And by abstraction, we've been able to look at it and say, yes, there are certain similarities between two possible subset of individuals that you want to consider. So for example, if you want to consider persons, you will realize that everybody has a name, everybody has an age, everybody has gender, so it could be male, female, and you have other things like locations, different things that you can use to classify who a person is. But by abstraction, we realize that it's about context. What is the context to which you want to describe them? So looking at the context, you say, okay, let's pick the things that are important to that context, and the things that are not necessary to that context, you move them away. Okay, so you don't use them, you don't work with them, and then you come up with a design of what a class should be. Now, after designing the class, you then realize that, okay, there are some, things you want to design a class for an employee now, and there are some information that are similar for both the employee and the customers. Whether you're a customer or employee, you have a name. Whether you're a customer or employee, you have an age. So instead of you having to define the employee class and start, writing names, start writing age and all those things, you just decide to inherit those characteristics. Okay, so you're inheriting those characteristics from the person. So things like name and age and things that cut across both of these entities, you inherit them, and you can then add on other methods or properties that you want to add to this. So here in the employee, maybe you can then add things like when the person was recruited, you can add the person's current salary grade level and things as such. However, that will not be found in the customer. So while you have inherited the person, you are not sharing exactly the same information between these two entities. Now within the employee class, you could then realize that, okay, this is a big business. You have maybe like a subset of level, and then in manager level, there may be different things you want to consider. Managers are also in level. You might have manager level 1, 2, and such. So given that consideration, you would want to, as much as possible, try to break it up also. So here you're going to be inheriting from the employee. So inheriting from the employee, you can then tag on some new information that managers should have. And then also for developers, you can also tag on that. So here we'll call the one that is the main class, okay, the class from which the other one is being inherited. You call this the parent class. You could also call it a superclass, while the class that is inheriting or extending from another class is called the subclass. Okay, There's other called the subclass of the child class. So that was the much we did in explanation last week. So let's continue from there. So here I have here an example of a person. Okay, so this is an example of a model. So here we have the person class, and this here is containing name, phone, and address. So this here is available, and here it has a method to which you can update the contact. So in case you want to update information, so you could want to update information such as the phone number or the address if such changes. So that could be a method available in the general person class. Now, while this method is available here, you come over and you want to create a customer class now. Now, this customer class is a child class. It is derived from this person class. So the first thing that happens is the customer class, when it extends, okay, or when it inherits from the person class, it takes in everything in the person, okay? It takes in everything in the person class. So everything here, which is including properties as the name property, the phone number property, the address property, and the method, it takes it as part of what it has. Then now we're tagging in along customer ID and the purchase, so in case the customer wants to purchase something. So these are two, and so here now this is a property, and then this is a method. So we can add properties if we want, or attributes, and we could add methods if we want. Now, this is another class, completely different. And this one here is also taking in or inheriting or extending over the person class. So it's taking in everything in this person class. And here we're tagging along, the employee ID attributes, and we are tagging two methods. So here we have promote and we have retired. So this is how it works. Okay, so this is how it works. You have the super class, is also called parent or the base class, and then you have the subclass, which is the child class or the derived class. So that's the whole concept of inheritance. You're inheriting methods, you're inheriting attributes from that class, and when you inherit it, you can then tag along new methods or attributes as you so desire. Now, there are different forms of inheritance, okay? There are different forms of inheritance, and I thought it good to try to show you at least the 5 major forms of inheritance, okay? So there are different forms of inheritance, but I thought it good to show you the 5 major forms of inheritance, so you will be able to put this concept when you are reading maybe like a programming syntax. So as you're reading the syntax, it sinks in, and you can understand what you're working on how to implement, with creativity. So here you have the single inheritance. Now this is a form of inheritance in which a class inherits one parent class. Okay, so one child class inheriting from one parent class. So that is the single inheritance. So you can look at it here, and it's also called simple inheritance. So here we have the parent class A, and then the child class B is inheriting from this parent class. So this is a single inheritance approach, and we're going to do this practically. Okay, so I always like to have a practical form of explanation of this in the code base. The next we have is the multiple inheritance. Now, an inheritance becomes multiple inheritance when a class inherits more than one parent. So it could be 2 or more. You can inherit from 2 or more classes. Okay. Now the child class, after inheriting properties from the various parents classes, has access to all their objects. So here we have a class here that has a function, and we have another class here that has its own methods and properties. This child class is going to take the properties that are available in A as part of its own. It's also going to take the properties available in B as part of its own. So this chart will help you to further understand multiple inheritance. So while this is receiving from just one class is receiving from another class, okay? So this child class is receiving from a parent. This one now is receiving is receiving all the properties from this and all the properties from this. So that is multiple inheritance. Now, the next we have is the multi-level inheritance. Now, the multi-level inheritance refers to where one can inherit from a derived class, okay? Thereby making the derived class the base for the new class. So here we have a class, which is class A. Class B inherits all the init properties of class A. And class C now is inheriting all the init properties of class B. So at this point, I want to try to see if I could explain this conceptually with realistic objects. So let's say we have here, let's start with class A. Let's say in class A now, in single inheritance, we have a class called animals. In the class called animals, you have like various types of animals available. Okay, so there'll be various types of animals. You could have goats, dogs, cows, sheep, tortoise and turtles and all sorts. All those will be within the class of animals. Now, if we create a dog class, the dog class could inherit certain properties that are available in, it's going to inherit all the properties that are available in the animal class. So what could be some of the methods, okay, or actions that could be available in the animal class? So let's put this in the chat section, okay? Let's put this in the chat section. Just mention at least one or two actions that animals do, that all animals do, okay? Something ubiquitous, something that all animals, do. Okay, so just mention some, so we can have some for reference. Quickly, I want to see answers in the chat section. Okay, just actions. Okay, and remember the actions basically what we refer to as methods. Okay, so I can see the chat section. Animals sleep. Thank you very much. Eat. Yes. Okay, I'll just take one more. Cry. Okay. I don't know if animals cry like crocodile tears. Okay, movement. Okay, so we take movement. All right. So we work with sleep, eat, and move. So all animals eat, sleep, and move. Okay, so we have 3 key methods, and this class B is going to inherit all of such methods. Okay, so the class B now is going to inherit all the methods. So if you create a dog class, the object that you create from the dog class will have all the methods available. Okay, this class now, this dog class will have eat, will have sleep, and will have movement. So all of its attributes will be available. Now let's look at some other class here. So here we have multiple inheritance, and it becomes quite, more of like a challenge to come up with storylines that would fill up with this. But let's look at this. Let's say we have dogs, okay, in one class. Let's say we have dogs in one class here, and let's say we have sports, okay. Let's say we have sports in another class, and okay, so here this would be specific to sporting. Okay, let's say sporting animals. So this could be dogs, and this could be sporting animals. And let's say dogs generally have some attributes like bark, like bite, and they are fast runners. They can swim and all that. And then sporting animals could maybe have some other attributes that are general to them. So maybe running and such and everything. So if you would be coming and see here, we're talking about the sporting dog, picking all the main attributes that a dog should have, and the key attributes that cut across, animals that could be sporting animals. So here it's taking properties from this. It's also taking properties from this. It's taking methods from this and putting this together, it can access anyone. So it doesn't have to access the two of them, but it has access to anyone it chooses. So if I want to pick a method from spotting animals, which would be maybe, or I don't know what spot cuts across all the animals, but let's just say, for example, let's just say athletics. Let's just say athletics. Maybe participating in the Olympics could be like a method. So participating in Olympics, let's call it a method now. Now, this class here can access this method. This class here can also access the methods that dogs have, eat, sleep, and all that. So this is multiple inheritance here. And then in multi-level, you have that you have this class as inherited from A, and it probably has tagged on some additional methods or functionalities. And this one here now comes and is tagging from B with all its methods that B has gotten from A. Okay, so all the methods B has derived from A, C now is deriving from B, and it is taking B as its its superclass. Okay, so B now is the superclass of C. C has access to the methods in A if the based on the fact that B has taken on its method. However, it is not accessing it directly. Like here, it's not accessing it directly. It's accessing it from what is available in B. So if in B, some of these methods are changed, C will be reaching out to whatever B has to offer. Okay, so here, a good example would just be animals in general. Another example for B now would be dogs, and then for C will probably be sporting dogs. Okay, so maybe sporting dogs, so dogs involved in sports. So you see now we've taken it down from being generic animals to being the dog, then from the dog class to being specific. Now we're talking about sporting dogs, which will be having its own new methods and functions that might not be available in B. It's going to add some new methods and functions. So that's the concept of multi-level. So in multi-level, you have inherit from here. This one is also inheriting from here. So this one is now the base class for A. Sorry, this one here is now the superclass. B is now the superclass for C, and that's how it goes. So let's look at the next or the last two. The last two is what we call hierarchical, the hierarchical inheritance. Now, in this kind of inheritance, various child classes inherit a single parent. Okay, so various child classes inherit a single parent. So here you have a single parent, and the various child classes, could be two or more, are inherited from one parent. So let's say we have the parent now as an animal, and the animal class here, we could then have a dog class, we could have a cat class, and then maybe we could have a bird class. So let's say bird, cat, and dog. Okay, so BCD. So you have a bird class, a cat class, and a dog class inheriting from the animal class, and that actually worked right. Okay, so that's the concept of the hierarchical inheritance. Various classes or various child classes inherit from a single parent. Then the last one we'll look at is the hybrid inheritance. Okay, hybrid inheritance. Now, when there is a combination of more than one form of inheritance, it is known as hybrid inheritance. So it doesn't have to be like this. This is just like like a simplistic way of trying to represent it. So let's say, for example, we have let's say, for example, now we have this is the parent class, and B has inherited some properties from A. C has inherited some properties and methods from A, and they've added their own new methods to it. Okay, so they've added their own new methods to it, and while they've added their own new methods to it, D is now trying to reach out to get from this. So D, being a subclass of B and also being a subclass of C, like we saw in the previous place, it was multiple inheritance. So here we're having multiple inheritance here, working here, and we are having the hierarchical inheritance working here. So you can see now this is no longer just one type of inheritance, either hierarchical or single or multiple or multi-level. Now what you're having is more of a combination of multiple inheritance, and that makes it hybrid. Okay, so you have single and you have multiple, and that makes it a hybrid inheritance. So that's generally the concept of inheritance. Now, the next we want to look into is called polymorphism. Now, the word poly means many, and the word morph means change of form. So in a nutshell, polymorphism would be the ability of an object in object-oriented programming concept now to take on many forms. Okay, the ability of an object to take on many forms. Now, it is an object-oriented programming feature that allows us to perform a single action or a single method. Okay, because when you see the word action there, it's basically describing method. So it allows you to perform a single action or method in different ways. So you have one method, but the method will be performed in different ways. Now, it is a mechanism that allows us to present the same interface, which is basically just talking about the method, the types, and all that. Now, it allows us to present the same interface for differing underlying forms, okay? And these forms could be data types. Now, there are generally two types of polymorphism. And these two types, first is called static. Okay, so the first is called static or compile time polymorphism, while the second is called dynamic or runtime polymorphism. And when we say static, basically it collects all, okay, it collects the information to call a method during the compile time. So the information it needs to call a method, all the parameters and things it needs to call a method, it collects it during compile time. So that's why it's called static. Okay. Now the dynamic polymorphism collects the information to call a method at runtime. Okay, so that's the dynamic or runtime polymorphism. So generally, from these two concepts, we have two key concepts. I'm not going to be explaining operator overloading because it's not widespread. Okay, it's not widespread, but I just put it up here so you can take time to check it out. Okay, now it has two key concepts, and the two key concepts of polymorphism, which is commonly discussed, are method overloading and method overriding. So method overriding is more of a dynamic polymorphism concept, while method overloading is more of a static or compile time concept. So I'm going to explain these two in details. But one of the key takeaway I want you to get from here is we have that in polymorphism, we're trying to have one interface that will perform multiple implementations. Okay, so you are performing a single action, but in different ways. So let's look at the two concepts we have here, method overloading and method overriding. So we started with method overriding. Now, method overriding in object-oriented programming is a language feature that allows a subclass or child class to provide a specific implementation of a method that is already provided by one of its super classes or parent classes. So it basically overrides or replaces the implementation in the superclass. The superclass has a method. The method does something in a particular way. But when you are inheriting the class, when you are inheriting the parent class, you decide that you want to override the method in that parent class. So you're not touching or affecting the parent class, but however, in your child class, the method that you inherited, you want to change it. you want to change the implementation that you have. So let's look at this chart for reference. So here we have the animal. Okay, I have the animal class, which is the parent class. Okay, we have the animal class, which is the parent class, and here it has let's just overlook the data. Okay, now it has two methods. One method here is move, okay, and the other method here is eat. Now, this method, as we are inheriting it into the dog class, we are now saying that we want a move method that is different from what is here or what is implemented here. So if here, the algorithm or the code or what it does or how it performs this function here is defined here in this class. When you come into this class, you are matching what you have here, in terms of the name and in terms of the parameters. And you are saying when you call the name and the parameter and you're matching it, you want to override the way it was implemented here. So in this dog class will have a different implementation. So let's say, for example, let's take for example, let me use financial term. Let's say, for example, we have how we calculate. Let's say this was interest now. Okay, let's say this was interest, and right now we're not specific as whether it is simple interest or compound interest. So let's say to calculate the interest here in this example here was talking about using simple interest PTR of 100, and that was the implementation. Then here you come over here and the interest you want to calculate now, you don't want to deal with simple interest. What you want to deal with could be maybe nominal interest or compound interest or some other form of it. At that point, you want to override what calculations or setup is here. And to do that, the implementation needs to match, the method in the same name. Okay, so the name, sorry, let me go back. So the name must be the same. Okay, the name must be the same. Then it must also provide the same parameters. So generally, they call this aspect of the parameters now, they call it the signature, okay? So this will be the name and this will be the signature. Now, by signature, we're referring to what kind of parameters are provided in this method. If this method here has X, Y, and Z parameters, then you need to match it here by saying also the same X, Y, and Z. If, for instance, here has only X, then it needs to have here also it needs to have only X. However, if you have X, Y, and Z, and in this place you come over and just say maybe X or XY, what is going to happen is it's just going to create a different implementation of it, which will be seen in the next method. Okay, so let me put this off. So generally, you have to match the name and the parameters or the signature as it's called, and also have the same return type as the method in the parent class. So by the time, or if you start working with TypeScript, or if you get into implementations like working with static types languages like .NET, you would then be faced with dealing with things like this return type. Okay, so you need to have the same name, the same parameters, and the same return type as in the method. So we'll see a practical example to let this knowledge sink in. Now, the second method we'll be looking at in polymorphism is called method overloading. Okay, I remember I described that these two methods are of different. You have here this method overloading is under static type. Then for dynamic type, you have method overriding. So method overloading, what really is method overloading? Overloading happens when you have two methods with the same name. However, they have different signatures or arguments or parameters, as whichever name you would call it or you're familiar with. Okay, so the methods have the same name, but now they have different signatures, different parameters, different arguments. So as such, it will be considered as, based on how you make your implementations, you can do different things. So overloaded methods are basically differentiated based on the number and type of parameters that are passed as arguments to the methods. Now, if you try to define more than one method, for instance, okay, we'll see this in practical. If you try to define more than one method and we give it the same name, give it the same number of arguments, the compiler is going to throw an error, because it's like when you're trying to declare a class that has already been declared, or you're trying to declare an object, okay, or a variable generally. When you're trying to declare a variable that has already been declared, it throws an error. So that's exactly what will happen if you have the same name and the same parameters matching for match, okay? So the thing here is, what differentiates them is the parameters you have. So this here now is one method with one name, and then it has a parameter, okay? Now, this other method here has like the same name, but however, now it has two parameters. This third method has the same name, and all of these are within this same object, okay? They are still within this same object. I'm not talking about having multiple objects or multiple classes now. They are still within this same object. However, now they are implementing different things based on the parameters that you have. So the advantage of method overloading is that it increases code readability and maintainability. Now, although it's possible to have like methods with the same name that perform a totally different function, the main takeaway is you want them to have like similarities in the concept of what they perform. So you're not just saying because they are going to have different, because they're going to have different parameters. The function, okay, should generally be an idea that does something, and whatever it is you are performing with it, remember that you are the one defining. You're the one that is defining the method. You're the one defining what the method will do. You're the one building the code. So in your own implementation of it, try to make sure that the purpose or what the methods do have that similarity, as related to the name and what the key function should be. So let's look at the pros and cons of OOP and get our hands busy with code. Okay, so generally the pros and cons of object-oriented programming is that you can work on real-world ideas or concepts because you're basically treating them as an object. So you're asking yourself, how do they interact or relate? An example of OOP in a very explosive concept would be CGI and computer-generated imagery. Now, in movies, when you build, for instance, maybe like an object or a module, maybe like a space or a building and everything. Now, if you were to create a virtual light, you need to determine how does the light interact with the other objects around. So if the light is an object, and if it is going to be shining on a particular, or maybe like in a particular environment, so you want to look at maybe how bright should the other elements look like in terms of distance, how further away should, the reflection, the light, the shadow, the angle. So basically, describing the light in an object, and you are describing how it interacts with other objects that are within that environment. So it's easy with the concept of object-oriented programming to create real-world ideas as opposed to procedure. In procedure, you are you're looking at like what you want to implement from start to finish, and it's not more of interaction. It's more of like the end result. So the code is not even reusable. What you do as a solution to an environment is not going to be reusable in another concept. However, when you see object-oriented programming, the code base are reusable because each object is clearly defined with how it interacts with other objects. So it makes it very great for real-world ideas and concepts. The next is when you use the concept of encapsulation, programs are easier to test and maintain, okay? They're easier to test and maintain. And as we saw when we were working with encapsulation, basically the first takeaway of encapsulation was, binding the properties, which could be the data, okay, the attributes, and the methods, binding them together into an entity. That was the first concept we looked at as encapsulation. And then the second concept we looked at was about hiding, the internal workings of it. So that was the internal, the second aspect of encapsulation we looked into. But here, this is talking about like the first concept, binding, and then you'll be able to easily test your code because everything is together, and then you know how it works, what works, and you can easily test and maintain. The next is fast development of code. Is done as we develop classes parallel instead of sequentially. So here, just imagine now that I am to build a class of what, maybe something, maybe I'm to build a class. A class could be, maybe like an authentication model. And Prosper is to build maybe a class that has to deal with maybe onboarding people. So creating a user account and all that and everything. And then another person now is to create a class on maybe file uploading. Okay, so uploading information to, our server. And then another person is to work on cloud storage implementation. All of us could go about our work individually, okay, and parallel at the same time. I could be building my class. The key takeaway is from what I'm building, how is it going to relate with, how is it going to interact with the information that should come in. So I'll then define, okay, these are the parameters that this class I'm building takes in, and this is the expected results if you provide these parameters as should be. So I'm defining how you interact with it and what it does, and then I have my documentation is ready, that code space is ready. So rather than us having to come together and start working on building everything in a procedural approach, and I'm waiting for, okay, who's supposed to start first? Okay, we're expecting that these people should start, and when they finish, then they will get back to us, and then we receive and we test, and then we start working our own. So it saves time. It brings about faster development because all the different developments could go parallel, could go simultaneously. Now, OOP provides greater security due to data abstraction, okay? So it provides greater security due to data abstraction. Now, the outside world cannot access hidden data. So this is, one of the concepts we saw in encapsulation. So we cannot access the hidden data information that is there. Then the next is reusability can be achieved by using classes that have been already written. So if I have created a model that does cloud storage perfectly well, tested and trusted, all I need to do is to pick it up and re-implement it. Okay. If I have built a model that does authentication, authorization, and all that, then tested and trusted, you can reuse it. So that's the key takeaway. So you don't have to go to start rebuilding based on procedure. This is what will happen next and everything. Your code is reusable, and that's the main idea of the packages. The packages that we download, using npm are basically just classes that have been well written, and they have the implementations and the documentation that explains to us how we should interact with it. So they're basically classes. So they could be like classes that have inherited so many different classes put together based on their structure, but they keep, you get the whole idea that it is reusable. So all I need to do at any point in time is to go, if I want to use Express, I just go and download the Express module or the Express class. And all the documentations I need to interact with Express is available, and it works. So I don't have to go and build another Express or to build another, React or Redux. All I need to do is just use the class, and so that's the key idea of OOP. So you can see how powerful it is. Now, the cons are that designing a program with an OOP concept can be very tricky, okay? Designing a program with an OOP concept is very tricky. It's easier to process what you want to do in logical steps or procedures. Okay, this is what I want to do from here. I want to do this from here. I want to do that. But when you begin to consider OOP, there are so many things you have to put into considerations, interactions, how do they interact? How do this, move from here to there? So it's a tricky concept, but we've looked at the pros. So let's continue with the cons. Now, a programmer needs to plan beforehand for developing a program in OOP. So you need to take time, in your planning phase. You don't just jump straight to coding. You take time to, break down your plan. This is what you want to do. This is how you want to go about it. Most times when I am asked to work on a project, one of the first things I'm asking is, I want to see your flow. I want to see your flow map. Okay, I want to understand the project, the product flow. I want to, see the user journey. So that gives me a better idea of what it is I want to do. So I don't just jump straight into coding. I don't just say, oh, I have this here, I have that here. Let me just pick this and not, and have a jigsaw of the code. So there is always a point of planning before you start developing a program. The next is the size of the programs developed with OOP is usually bigger than those developed with procedural approach. Okay, so in a procedural approach, looking at the text file, let's say for instance now, in text, if you're using a procedural approach in text, basically what you're doing is you just instead of you having things like import statements, having things like exports, having to come up with new definitions and things and everything. If you notice, people who YouTubers who do their code based on one file in a console, maybe like one file, just index.js, you realize that shorter lines of code as compared to when you start breaking it up into folder structures, and even in terms of the file size, it will still be larger with OOP concepts. And the last here is, since OOP programs are larger in size, it also affects it in terms of execution time for this program, because you have to make calls to this, to import this into that, unload and all that before execution. So it affects execution time, but we've looked at the pros and it makes it a lot more easier to use OOP concept. So it's a widespread use concept. So let's get straight into practical terms. So before we go into practical terms, let me pause for a bit, and I would like to take questions if there are any. Okay, so do we have any questions from before we go into the code section? If you have a question, you can raise your hand, so I can try to answer your question. Okay, I have one hand up. Okay, two. Okay, I have two hands up. Any other? Two hands. Okay. Okay, three hands. Oh, great. Okay, that's great. All right. Delight, let's go with your question. Okay, so you can mute your microphone and go with your question.
All right. Good evening, everyone. My question is related to the polymorphism. When you say compile time and run time, I'm not exactly clear on those two terms. If you could clarify.
Okay. All right. Now let's talk about what a compiler is. Okay. A compiler is basically more of a program that's tries to put together all the necessary steps, setup, and everything, before it runs the program. So it will try to interpret, to try to interpret the language and convert it to machine code before it runs. So all the different checks and everything it wants to receive, it wants to make sure that they are available before it starts running the program. So for instance, one of the things you look at is type. You are familiar with types. We have integers, bool. We have, okay, let me speak in more JavaScript terms. So you have Boolean, you have arrays, and different types of data. Now, JavaScript as a language is more of a dynamically typed language. So it doesn't ask or check for the type before it starts. It does that at runtime. But if you're working with languages like C#, like Java, you usually see them specifying something like string. Instead of you having maybe like var name is equals to the name of somebody, you have something like string. So that string here would be what would be the defining factor of the type. So for the one, let's go to that page. Okay, for the one, for the one that deals with okay, I'm covering this. Page, I think this page. Excuse me. Okay, so for this static or compile type, it will first of all check to get all the information. Okay, it's going to check to get all the information, all the parameters, check the type, check the structure and everything before it will then lump it up together and say run the program. However, in the dynamic or the run type, it is going to run the program, and as the program is running, it will then be doing the comparison, checking for type, checking for things that it wants to do. So explaining it now in terms of, explaining it now in terms of overriding. Okay, now using overriding, let's say, for instance, we have this method here, move, in this class. It is when you create an object with this class, okay? When you create an object with this class, the object at runtime, okay? When you want to access the object at runtime, it is first going to check this class. Now, this is happening at runtime, okay? It is first going to check this class and ask for, okay, do I have a move function in this class, okay, that is overriding this? If there is none, okay, let me check the parent class for a move function. So this is happening at runtime because here it does not know at first that if there is any move here in this dog class specifically, because the dog class can be inheriting the move from this animal. But now, since we have move here, it will first check, is there move here? Okay, if there's a move here, then I want to override the one that is here. Okay, let's check now. We have a back here. If there's a back here, I'll just give you the result of what back does. I don't need to come and check here. But if I have it will check it if it is available here in this dog. I'm talking about this it here. If it is available here in this dog. If it is not here in this dog class, then let me check the parent class that it is receiving from. So checking the parent class, it sees an it. Okay, let me perform the method that the it method does. So that's the difference. But when we look at the static type or the compile type, here now, you can see that these are parameters. Before it will even get to the point of running, it wants to ask, are these parameters available? This method that this object is trying to reach out to, where the parameters provided, if the parameters are not provided, where the person is trying to access it, then it will not even run. So it will give you an error even before you get to the point of running. Okay, so that's the difference between them. So this one here, it will try to compile, and before it will run the program, if you back then, when I started programming much long ago using simple language like Fortran, we have a command for build and we have a command for run, and those commands are exclusive. Okay, they are exclusive. So you can try to build a project which is basically the compile, and then you can choose not to run. If you're also using .NET, .NET also has a build command, okay? So you can build, and if you try to build, if there's an error in trying to compile, it will tell you, and if there's no error to build, then you then have another command for running, okay? So either you want to use the debug to test it. So because we are using JavaScript, which is dynamically typed, there are a whole lot of things, okay? So JavaScript is not like wholly an object-oriented programming language. So that's the reason why some of these concepts are not quite sinking in, but I'll try to explain this same approach when we get to the practical test. But I actually hope I've been able to answer your question. Were you able to get the concept and the light?
Yes, I have been. Thank you.
Okay. All right, you're welcome. Okay, Moscow Tech, go ahead with your question.
Okay, so good evening, everyone. Can you hear me?
Yeah, I can hear you. Good evening. I can hear you. Go ahead with your question.
Okay, yeah. So my question is in line with them. Question is hybrid inheritance. Can you hear me?
Yeah, I can hear you. Go ahead.
Yeah, in case you have a situation like an hybrid inheritance, where you have a superclass, then you have a super class. So in case one of the superclasses have a function being overridden, then how does the base class handle it? Does it have like
okay. Well, if I understand your question very well, the way you should consider it. Okay, the way you should consider it is you should consider it from multi-level inheritance. Okay, now if you look at the multi-level inheritance concept, this is class A, class B, and class C. Class C here does not inherit from class A. It is inherited from class B. So it's whatever methods class B has available that class C knows. So if B inherits from A and overrides what is available in A, then C does not know anything about what happened in A, does not know what was overridden. C just says, okay, I'm going to take all that B has. Okay, did you get that?
Yeah, thanks.
Okay, so that's how it flows. Okay, so you have A, you have B that is inheriting from A. Whatever B does to it, that is what C is going to realize. It's not the same as when you have this here. C is reaching out to both of them individually. So, well, it's what A does not affect the implementation of what B does. Okay, but when you come over to this place here, whatever B does to alter or to override A, that is what C is going to see available, and that's what C can reach out to. So generally, that's how it works. All right. So there was a third question, but if I've already answered your question, let's go straight into implementation. Okay, so let's go straight into the implementation. All right. So let me go over to VS Code. Okay, just give me a second. All right. Okay, so we're continuing from where we stopped here. So I basically renamed this here. This one contains all the things we looked at last week. We looked at abstraction. encapsulation, and we looked at examples. Okay, so it's still available. So I'm creating a new file which I would make available to you. So here we have some of the concepts we see today that we would like to demo in practical terms. Okay, so what would be a good way or good exercise to demonstrate this? Let me start by looking at what key concepts we talked about today. So let me just share my whole screen so that I can move between the slide and between the slides still up. Okay. So I can move between the slide and here. Okay, so we started by talking about single inheritance, and here in single inheritance, what we are talking about is one-to-one. Okay, so one child class inheriting from a parent class. So I think we talked about it using a dog as an example. So let's have an animal class. So we have a class animal, and this class animal is available. And one of those things we looked at, we said that it could have things as it could have attributes, or let's say it has a method. Okay, so let's say it has a method as right now I don't really want to put anything in constructor, but okay. Okay, so let's say we have action. Let me just call it action. Action is a reserved keyword. I don't think so. Let me just call it action. Okay, or let's say doing. Okay, doing something. So let's say doing something. Okay, doing something sounds okay. So let's say doing something, and this is a method available in the animal class, and the method does sleeping. Okay, sleeping. Okay, so yeah, so let's say the method does this sleeping now, and then we want to take this class here, okay, which has this method that says do something. Okay, we want to take this class and extend it. Okay, so we want to have a dog class that extends, okay, or inherits. The keyword is extends when you are working with JavaScript. Okay, so dog class extends animal. So basically it has inherited from the animal class. Okay, so if you look at this here, you see class animal. Okay, so the dog class has inherited from here, and for you to be able to inherit the properties, okay, for you to be able to inherit the properties of the other class, you need to call the super, okay, the super constructor. So you need to call the super. This is because this is the super class, okay? So you want to pick the methods and the parameters that are available, okay? You want to pick the methods and the parameters, okay? The methods and the, attributes that are available. So that's why we're calling the super. So the super is used in calling that. So here now, if I was to create an object now, okay, let me just use const, okay. If I was to create an object, a dog, and I say the dog is a new dog, for instance, okay. Now, I can access the attribute of the animal. So I can say dog dot do something. So if you look at it here, you can see that this method here, you see what it's saying here. It says animal dot do something. I don't know if it's large enough for us to see. Please, can somebody reach back to me? Prosper, is it large enough? Is it legible enough for everybody to see? Is the text large enough for everybody to see?
Yeah, it is.
Okay, great. Okay, if you're watching on YouTube, you might need to increase your screen the pixels to 720. That's so that you'll be able to see the text clearer. So I use 720 normally if I want to see the text on YouTube. So for those watching on YouTube, you can increase your the pixel from 360 to 720 so you can see the text clearly. All right, so here I can access this method from the animal. As you can see, it says method and it's from animal, and it's basically saying animal.do something. Okay, so if I say animal.do something, it's going to do that method that is available in the animal. So let me do this. Okay, so you see now it says sleeping. Okay, so it is reaching out to this method here in the animal class. That's because I have the super. Now, if I take the super out, let me take this out. Okay, so I've commented it out. You see what's going to happen. You see now it's throwing an error. And what is the error saying? It says must call super constructor in derived class before accessing this or returning from derived constructor. So to be able to access what I have in this, I need to call the super. Okay, so the super is for you to be able to access this keyword or things that are available within the constructor. Okay, within the constructor of the super class. All right, so let me clear this out. So this, so that very much settles it for single inheritance. So for single inheritance, as we've seen here, we've been able to inherit from the animal class, and we could access the properties that are available in the animal class. Now, going to multiple inheritance. So in multiple inheritance, how we looked at it is we said you could have, like one class on one side and another class, and the two of them together, you can pick the properties that, are from the two, okay, to do the same. So I still find it hard to conceptualize what I can use as an example right now. Okay, what can I use as an example for two classes? Let me just use let me just call it class A. Okay, so I'll just call this class A for lack of ideas of what it could be. So let's just call this class A. Okay, or okay, so class A. Oh, sorry, please, I missed out the parameters. So let's say class A, the constructor, and here I don't want to do anything. Okay, I don't want to put right now. I don't want to bind properties here. I don't want to receive any property from the object yet. Okay, so let's just give it like what should it do? Okay, let's just say a method. Let me just call this a method. Okay, let me just call this a method. So this a method now, I want it to, okay, I want it to just console the blog method from A, okay, method from A class. Okay, so that should do. Let me comment this out so we have a clean ID. Okay, so this is method from A class. Okay, and then I want to console. Sorry, I want to create the second class, class B, and here I want to also do the same thing too. So I need a constructor. Then I'm not passing parameters or anything. I don't even need this open. And here I'll call this B method. Okay, so I'll just call this B method. And here I want to console.log, okay, method from B class. So here will be method from B class. Okay. Now, okay, so going by this now, I have A class and B class, and these two have I want to have like class C, okay, class C that is going to extend. I don't think I've even done this before. Okay, so class C extends class, or how do I even do that? Maybe class C extends class A. Okay, class C extends class A, and do I separate this? Okay, and I don't think I've done that. Maybe I'll take time to look into this. Okay, maybe I'll take time to look into this and see how to do that. I don't think I've done this. Okay, I don't think I've done this. That would be a good approach. But maybe I'll just take time to check this out. So the fact is that most of the time you don't want to have, okay, most of the time you don't want to have multiple what do you call it, multiple inheritance, because the challenge with multiple inheritance is it usually starts from taking multiple inheritance. We first consider the left from left to right. Okay, we consider from left to right, and as you can see here, it's going to have some point of confusion. Okay, it's going to have some point of confusion of what to inherit. So most times, most languages, especially like dynamic type languages, don't do multiple inheritance. Okay, so I don't think I've even seen the concept in practice. So I think for now I'll just leave it be. Okay, for now I'll just leave it be. Let me not put any method here since it's just doing a super. Let me see if I could access. Let me see if I could access this. If this doesn't work, I'll just check it out then. If I find a solution for that, I can reach out to you guys. So let's just call this C objects. Okay, C objects. Let's just call this C objects. And C object is equals to new C. Okay, C object is equals to new C. And what class is C receiving from? Okay, C constructor. Okay, all right. So let me see if I can access the objects from a method. Okay, I can see a method. Okay, I can see a method, but it's not coming here as an object. Let me see if I can access B method. I can also see B method, but it's not coming here properly. So that confusion is, I called C, not C objects. Okay, so let's say C objects. So let me see, let me check it again. Okay, so I can access B method. All right, let me see if I can also access let me see if I can also access a method. Let me see, a method. Okay, I can't access a method. So I have a challenge here in how I set this up. Okay, so but here I can access B method, but I can't access a method. So I'll check out what is the challenge here, and basically I'll get back to you guys on this, on using multiple inheritance, but it's not something you should really bother about because it has its issues. So most times people don't want to use multiple inheritance, especially in static type languages, Java, C# and such. Okay, so I'll just leave this commented out for now. So let's go and try out the multi-level inheritance. Try to answer the question that were asked before. So let me use this. Let me use class A and class B. Okay, so let me use class A and class B and do this here. So so I don't have to go through the stress of typing this again. So what I want to do now is, this is multi-level inheritance here. Okay, this is multi-level inheritance here. We have A, we have B, and we have C. Okay, A, B, and C. And we want C to inherit from B. So let's do this. Okay. So here A has a method and B also has its own method. So I'm going to say class B extends. Okay, so class B extends A. So and for me to be able to pick the methods that are available in A, I have to call the super. Okay, so I have to call the super constructor here in this. So if I do this, I could then have class C. Okay, but before I go to class C, let's test that B is working. So let me start by saying, I'll call this B object for now. Okay, I'll call this B object for now. Okay, is equals to new or B. Okay, so, and if I was to access a method from A using B object, okay, so let's see, I can get the A method, okay, and let's test this here at runtime. Okay, so let's do this node 1 and 2. Okay, all right. So you see here in B, I can call this method from A. Okay, and it says here that method from A. Okay, now I have added a method in B. So B also has its own methods. Let me bring out the method from B. So let me call this B method. And you see here, I have the method from A. I have added the method in B, and it's finally available also. So I've tagged another method in B. Now I want to create class C. Okay, I want to create class C now. And the class C now should extend B. Okay, extend B. And okay, so I have the constructor. The constructor, in the constructor, I want to call super so I can pick out what's available. And then here, I want to just tag another method so that we could have method in C. So C method here should, okay, let me just pick this out here. So C method here should, okay. Okay, so let's call this method from C. And then here now, I want to create this new object. So this object, I don't want to use B any longer, okay? So let me change this to C. Okay, so C now, and C should access the C object, okay? So here, I want to say C, and I want to say C. Now, if I do this here, you see here that C can access the A method. Okay, C can access the A method because the A method was passed across down to B. And since B could access the A method, then C can access the A method. C can also access the B method, and conversely, or rather, also consequently, C can also access the C method. So we have all three methods, A, B, and C. Now, what I want to do differently is when we get to polymorphism, I'm going to pick this from here, okay? I'm going to pick all of this from here and take it into, I'm going to take all of this from here into a polymorphism, okay? So I'll just pick this from here, and I'm going to use this in explaining overriding. Okay, so I don't want to explain overriding now until we get there. So we know that all of this concept is based on inheritance. All right, then, so that's about inheritance. Then the next I want us to look at is the hierarchical, okay, so the hierarchical inheritance. So this hierarchical inheritance, it's basically, when you have one parent, okay, one parent class, and you have like multiple child classes from that one parent. So here, a good example would be you have a class like the animal class. Okay, so let me comment all of this out. So let me comment all of this out so you have a clean IDE. Okay, so all right. Okay, so we have the animal class, and this animal class, let's just have a constructor. Okay, so let's have a constructor, and for now, the constructor should not have anything for now. Okay, I don't want to complicate anything. So let's just say, okay, let's okay, I don't want to go into like complicating things because I don't want to talk about polymorphism yet. So that we understand all I'm talking about now is inheritance. So when I get to polymorphism, some of the things that I'm avoiding doing now, I'll do it there, and then you see what I'm talking about. So let's have like a method. Okay, so this method would be it. Okay, this method will be it, and it should be console.log munch. Okay, so let's just say munch. Okay, so let's assume that this is how animals eat. They are munching. Okay, so munch. All right. So this here is a class, and if I was to have another class, so this class could be A, B. Okay, so B could be birds. Okay, so we have a bird. Okay, so we have a bird class, and this bird class has its constructor. The constructor has the super for it to receive the properties. Okay, and then after the bird class, we have the carts. So let's say we have carts. Okay, so we have carts, and then we have the dog class. Okay, so we have a dog class. So we have here the animal class, we have the bird class, and we have the cat class. Okay, so let's say for birds, what do birds do? Okay, so let's say the birds have a fly class. Okay, so let's say the birds have something special to them, which is fly. Oh, used wrong. Okay, fly. So console.log, okay, console.log can fly. Let's say flying. Okay, flying. All right, and cats. What do cats have? Okay, so many things. Okay, dogs and cats also scratch. Okay, let's say meow. Okay, let's say meow. Okay, so let's say meow. Okay, so okay, so let's console the dog. Okay, doing some meow sounds. Okay, and okay, and then in this class here, okay, in this one here now, let's say what we have now is our bark. Okay, so the dog can bark, which is a method. So console.log or barking. All right, so barking. Okay, now all of these classes have basically taken, okay, has basically taken everything from animal. This bird class now, I wanted to take stuff from the animal, but if you notice here, I've not extended, which is a mistake on my part. So I wanted to extend from the animal. So I wanted to take on what is available in animals. Okay, so let me just copy this here. I want this to take what's available in animal, and I also wanted to take what's available in the animal class now. So if I was to create, for instance, now, maybe like a dog, okay, I was create a dog. Now from the dog class, all of these are animals, okay? The dog is an animal. If I was to, let me just, okay, let me just type this. Okay, so new cat, okay, for the cat, and I think let me just do this here. Bird, okay, is equals to new bird. All right. Now, these objects that come from here, the bird class can access the eat, which is a method belonging to animals, okay? So it can access the eat, okay? The cat class can also access the eat, okay? And the dog class also can access the eat. So basically, they are all inheriting from the animal class, and it allows them to access the methods. And if we have properties, also the properties that are in the animal class. And then you can also tag along your own additional properties. So each one of these classes now can also have its own properties. So for instance, in the bird class, we had additional properties like bird can fly, okay? So we had in the cat class that the cat has additional properties or methods that you can use like the meow, okay? Then we also had that in the dog class, the dog also has its own additional, methods like bark. However, the bird cannot bark, okay? This is not a class available in, or it's not a method rather, it's not a method available in the bird. The basic idea of That's the basic idea of the hierarchical. Okay, so the cards here can, both of them, if you look at it here, you have the bird is taking the munch, the bird is flying. The cat can munch, the cat is flying, sorry, doing some meow sounds, and then the dog also is also doing the munch, and the dog can also bark. So in the what do we call it now? The hierarchical inheritance. You're talking about having multiple, okay, multiple child classes of one parent class. So that's the concept there. So let me just compress this and comment all of this stuff. Okay. All right. So that's the key concept there. Then the last one, okay, the last one that we had there is also not quite much of a common concept. Okay, it's quite not much of a common concept, or it's not much of a nice concept that people use. Okay, so but here you're having a combination of one form of inheritance, of more than one form of inheritance, and this is basically known as hybrid inheritance. So it's not something that is commonly used because it becomes hard to track what is doing what. So if we had been able to do this multi-level inheritance part, okay, no, not multi-level, the multiple inheritance part, if I was able to do that, I would have demoed that for you to see the complexities that are involved with it. But let's just stick to the three key ones that are used. Okay, so let's just stick to the key ones that are used. So single is commonly used, multi-level is commonly used, and this hierarchical inheritance commonly used. But hybrid is not so commonly used for challenges that come with it. And multiple inheritance, as a matter of fact, dynamically typed languages, they avoid it. Okay, so Java avoids it. Okay, if you want to still go check it out yourself, you're welcome. All right, so before I go into method overriding, okay, before I go into method overriding, let's just look at this chart once more. We said in method overriding, which is a polymorphism, okay, the key takeaway is we have like one interface that does multiple implementations in polymorphism. So here in method overriding, what we are saying here is we have a specific implementation that is available in the parent class. However, you want to override that implementation when you are inheriting the child class. So you have to match it. Okay, so you match it, first of all, name for name, and then you match it in signature. So the signature basically is what we refer to as the parameters. Okay, so the parameters are the arguments that are being passed in the signature. So let's quickly demo that. Here. So I want to use the animals. Let me use the animals. Okay, so let's use the animal class and the bird class to demo that here in inheritance. So I'll call this method overriding. So I'll call this method overriding. Okay, so let me use this to demo that. So here we have class animal. Okay, all right. All right. So we have here class animal, and here we have it. Let's change this to sound because right now I can't tell how birds eat. Okay, so let's change it to sound. Okay, so the sound made. Okay, so let's say in the sound made, we have a generic sound. Okay, let's say we have a generic sound that animals make, and we don't know, so we just say make sound. So just say we have make sound. And mind you, this could be like an elaborate function. I'm just trying to make this as simple as possible to stick to the main idea of understanding the concept. So here we have here in this class animal, we have here a name of a method here, and we have the parameters that are provided. Okay, so here in this place, what you want to do is you want to you want to match, if you want to override what is here, you want to match it, okay? So here now, I have a class fly, and I want to leave this class here. Sorry, a method fly. I want to leave this method here. So I want to override this to make the sound. Is it a chirp sound, or what sound do they make? Is it a chirp? So let's just call it a chirp sound, okay? Because there's so many birds. Let's just say a chirping sound. Okay. Now, so I'm going to say sound made, okay, and I am going to then match. So I've matched the name and I've matched the parameter. So what I'm going to do now is I want to change it from being, okay, I want to change it from being just make sound to makes chirp, okay, or chirping sound. Is it double P, or that just makes chirp sounds? Okay, so let me just say chirp sounds. Now, let me check. Do I have this running here? Okay, let me see. All right. Now, so this here is the come in, please. Okay, so this here is the animal class. This is the bird class that is extended over the animal class, and I want to create a new object in it. So I'm going by const. I'm going by bird. Okay, small letter because I have the new. Okay, so bird, and I have a new bird. There are no parameters. I'm not doing parameters. Now I want to access the object. Okay, so the method here, sound made. And if I access the method sound made, you see here, what I am seeing here is makes chirp sounds. Okay, so it's making chirp sounds. This is overriding what this one is. So this one here is saying make sound, but here now this one has overreading it because I matched its name and signature. So by name and signature, I matched this, and I can hence override this. But if there was some slight difference, okay, if there was some slight difference, like let's say for instance now I was to let's say for instance I was to call a new parameter now. Let's say I have a parameter here, sound, okay, and this parameter now, let me call it chirp. Okay, so let me call this parameter chirp now, and let me use this parameter here in a string literal. Okay, so in a string literal, sorry, let me say makes okay. All right, now sorry, it's supposed to be sound. That's the variable there now. Okay, now where am I? Okay, now what you see here is you are seeing undefined. Okay, you are seeing undefined because I am not using the this keyword. Okay, I'm not using the this keyword, so it's not reaching out to it here. And this sound here, for me to use it here, I need to pick it out from here, sound. Okay, so then I need to do the this dot sound is equals to sound. Okay, so sound is equals to sound. All right, then okay, I won't need this here again. Okay, all right, so yeah, I won't need this here again. So basically here, okay, what you see here is I have made like a new implementation of this here. Okay, I made a new implementation of this here, and what this one is doing here is I'm receiving a parameter from here. Now this sound made here is not using, they're basically the same signatures. Okay, they're making the same signatures. So let me try to see, let me try to change, okay, let me try to change this so that it's using the signature coming from here. Okay, using a signature coming from here, coming, sound, coming. Let me do this. Okay, I'm coming. Just give me a second, please.
I think you need to pass the parameter on the bird.sound mode, like on the sound mode itself.
Yeah, I know. Yeah, true. Thanks. Okay. Yeah, the check. Yeah, the sound mode. Yeah. Okay. Yeah. Thanks. Okay. Yeah. This that works. Yeah. Thanks for that. Okay. Now, what I want to show you here, okay, is that here, if I have bird.sound made, okay, bird.sound made here, what you will see here, okay, from bird.sound made here and this other one, okay, this other one here is trying to access, okay, this other one here is trying to access the what you call it, the implementation of this one, okay, it's trying to access the implementation of this one here because I passed this here, okay, I passed this here. So let's go over to polymorphism in the other aspect, and let me see what I'm getting to that. I think so that I don't get carried away here. Okay, so let me try to go to that. Then with this, I'll check out what I'm doing wrong here. All right. Okay, so here I passed the trip here in the bird, okay, in the constructor here, and okay, and here I'm trying to access this from here instead of going to this of sound, okay, so instead of going to this of sound, receiving it from this keyword. So okay, so what I have here now, this method here is one thing on its own. This is what I wanted, okay, this is what I wanted. Then basically what I'm trying to show here is I can also pass a parameter, okay, from here. I can pass a parameter from here, and it can still go. If I was to pass a parameter, I'm receiving it here in the constructor, doing this dot sound to bind it here. And this implementation is exactly the same as this other one. So for this one, it is still overriding, okay? It is still overriding. So when you have that the name and the signature are the same, we call that overriding. So I want to go over to the next one, which is called method overloading. Okay, so method overloading is where we are going to do this same implementation, but now with different signatures. Okay, so what I want to do here in this method overloading is I want to use this same. Okay, so I want to copy this and comment this one out. Okay, so I want to use this same one here to do the same thing. Then let me put this one off so that it doesn't distract the class. Okay, because when you see errors going on in a live class, you feel like what's going wrong? Meanwhile, it's just something that you take time to look at and you spot your errors. All right, so here I am still doing the bird. Okay, I'm doing the bird extend animal, and this time around, okay, I have sound made. Okay, I have sound made by the animal, and the main idea when working with overriding is you want to have what you call it, you want to have like different implementations. The signature will be different. So when we talked about signature, the set signatures could be things like methods. Okay, so you can have parameters here, and everything. So yeah, I have X, Y, Z, X, Y, and everything. So I just want to use like a simplistic example. Okay, so I want to remove this .sound and leave it here. We've seen this is working, but right now I don't want to use this. I just want to use or make chirp sound, so I don't need to complicate this. Then I can take this out because I'm not using the parameter any longer. So I can take this out, okay? And I can do a const and get a bed out to have a bed object here, and now that this bird object is, okay, I have another bird object. So yes, this was the second thing I was talking about. I was saying like when you have one variable, okay, or parameter or what do you call it, a method that is exactly the same in terms of name, it's going to throw you an error. So if I was to run this now, okay, it's going to throw an error because of this. So that's also the same way it works in having a method, okay? So here, I want to say, I want to use only one, okay? So let me remove this one, okay? I want to use only one, okay? So I have fly. So let's say if I have an implementation of bird.fly, it's going to console.log flying, okay? And you see it here, console.log flying. But let me use Node to run this instead of NodeMon. Okay, so let me use Node to run this, so that way people don't get confused. Okay, so let me use Node to run this. All right, I think that's close now. So here, if I do Node, okay, and I run this, it's going to say flying, and it says it once. Now, if I was to add a parameter, okay, like maybe a number of times it's going to fly, okay. If I was to add a new parameter now, like fly, and maybe n, okay, and here I want it to probably just do the same thing, okay, console.log fly, flying, but that's not exactly what I wanted to do, but let me just have that out here first. So let's say we have console.log flying here. Now, you notice that this works, but if I was to comment this out here, and NodeMon would have been best to show you the error. Okay, so NodeMon would have been best to show you the error in the page. Okay. Now, generally, if this was a static type language, honestly, this would be crying an error. I don't know why it's working on JavaScript, but that's all the funny parts of a dynamic type language. Okay, but generally here, if I say bird.fly with Node, it's doing just that one thing, okay, that Node does, okay? It's doing just that one thing. So here it's doing flying. But here, if I was to say, for instance, let me take n and let me make this a loop, okay? So let's say I say for, or maybe like for I equals to, for I 0, and maybe I say I is, less than maybe n, okay? I is less than n, and I say I plus plus, okay? So while I is less than n, I plus plus, I want you to console.log this, okay? So if I was to do this, okay, just this your regular for loop now, this should run like 5 times. If I was to do this now, and I was to run this, you would notice here, what's it saying? It says I is not defined, okay? Come on, I did I is equals to 0. For I, okay.
First, the let keyword on the first of the I.
So you said what?
Keyword like for let I equals to 0.
Oh yeah. Oh, thanks. Sorry. Thanks. I actually thought it would escape. It seems like it's not supposed to. All right. Thanks for that. All right. Okay. Now, the challenge here is JavaScript is not a, what do you call it now? JavaScript is not a static type language. So basically what's happening here is that this JavaScript, what it's doing here is that it's when it sees fly here and it sees another one here, it's basically overriding this one here. So I've not actually really tested this implementation before here on JavaScript, but what I'm seeing here basically it has to do with the type conversion. If I was on .NET, this same method, what it would do is it would take them as two different methods entirely. But however, it's surprising, surprising how JavaScript works. But I hope you get like the takeaway. Yeah, I hope you get a takeaway. The main challenge here is, like I said, JavaScript is not primarily an OOP language. Okay, it's not primarily an OOP language. That's one of the reasons why people look into TypeScript. Okay, they look into working with TypeScript to deal with these issues. So for certain applications that deal with concurrency and things like that, you have to use TypeScript for this implementation. So for me, it's even surprising me. I haven't really tried this before, but this syntax is the way you would do it if you were actually really working with another language. So I would just say this is the challenge of working with a dynamic type language. For JavaScript, I remember when we were talking about this, we said that this method overloading is more of a static type, but JavaScript actually compiles at runtime. Okay, it does its work at runtime, the typing and all that at runtime. So that should probably explain why our results are not working as expected from an OP language. So that's already even pointing out to me the limitations of working with JavaScript. So I think that clearly enough sums up limitations of working with JavaScript for some things and why we should work with TypeScript. Okay, so I'll take questions. We've gone far ahead in today. I probably should have practiced this to see that this was not going to work with JavaScript before giving it a shot. But well, all the same, that's great. It's a pointer to what really we talk about when we say, static type language and dynamic type languages. All right, so I'll take questions. If you have questions, you can put your hands up. So if there's any aspect you want me to go over. Any questions? If you have questions, you can put your hands up, okay? If you have questions, or I think I should be looking at everybody face to face now. Any questions, please? Okay, okay, all right. So if there are no questions, I want to believe we've been able to get the bulk of, okay, all right, great. Okay, I can see one hand up. Moscow Tech, you can ask a question.
Okay, so the thing is, I was going to research it online, so I just wanted to ask that super function. Is it editable or something? Is it just paste it super function in the construct of scopes?
Okay, you mean the super construct that we have there?
Yes.
Okay, is it editable? That's what you're asking.
Yes.
Yes, it is. Yes, it is. Okay. Let me share my screen and show you. Basically, we edited it. Okay, it's just that I didn't do the edit here. If you look at this here, okay, this override didn't quite work. Sorry, the overloading rather didn't quite work because JavaScript compiles at runtime. Okay, so it didn't work. So let me go to method overriding because this worked because this is a dynamic process. Okay, it's something that runs. So I can use this to explain what I want to talk about to you. So here we have a method here that is called soundMade, and we have a method here that is called soundMade. So basically, I'm overriding this method. Now, we were asking about like the super. Okay, you're asking about the super construct. If there are things that we can change. So here, what I want to do is let me have something. Okay, let me have something available in this place here. Okay, now if for instance here now I had this up here, okay, if for instance now I had this up here, and this was like this dot sound as like a method that was how do I put it now? Like a method now that's available. Okay, coming. Let me do normal function setup now. Now, if I have this here now as a method here that's available in this place here, I'm also going to receive it here. Okay, it's just because, like I showed you in the other class, if you bring it out, you're no longer using this keyword. However, it's still available to the whole place. Now, what we did here now, I also want to take this one up so it goes back to looking similar to the other. And then I have to, at that point, change it to function syntax and set it to be this dot sound. Okay, so if I do this, I have basically, overridden what is available here. Okay, so if I do this now, the fact that I can, let me see if every other thing is commented out. Okay, so yeah, so let me run this here. Okay, now if you look at this here, it says make strip sounds, but what I have here in animal here is just make sound. So I basically use this here in the super to override this. Now the super here, another thing here is if I have, apart from functions here, if I have variables that are available here in the super, maybe for example, in the constructor, let's say, let me not put function, let me say I have this dot name now is Kingsfisher. So let's say I have Kingsfisher, okay, Kingsfisher as the name of this bird here now. Now, if I want to be able to access, the bird name here in this place, okay. Now, it's available here, and I can console.log it. Okay, so I can console.log or bird.name. Sorry, please. I can console.log bird.name. So if I want to change it here also, okay, let me just put node one to run this. Now, if I want to change bird.name here, I can also change bird.name. But for me to change the bird.name in this place, I have to try to reach out to it, okay? So I go by saying bird, and then I then pick this dot bird is equal to then the name I want to give it. So maybe like comment please. So generally, okay, anything you want to reach out to, okay, anything you want to reach out to, you can pick it out, okay. You can pick it out from the super keyword. Sorry, please. You can pick it up from the super keyword. This is very equal to what name can we give it now? Or I don't know that bit. Woodpecker. Woodpecker now. Now you can change anything that you want to change. Okay, you can change anything that you want to change here, but you have to reach out to it. Okay, you have to reach out to it to come in. Let me check what error showing. Cannot access bird before initialization. Cannot access bird before initialization. Please just give me a second, please. Cannot access bird for initialization. Where is it initialized? Bird. This bird name. Okay, cannot access. Okay. Comment please. Let me check what. Let me pause this. So okay. Now I'm coming out. I'll check this out. Okay. But what I was saying here, just give me a minute. Sorry, I'm making some error here. Now, what I'm saying here is like you can change certain things. Okay, you can change certain things about like an entity, okay, like the way we changed it here, like the way we changed the function here, you can override it here. But I think the challenge I'm doing here is I'm trying to override it in this place. Okay, so I'm trying to override it in this place. So let me do that change from here. Let me do that. Let me take it here as a parameter. Okay, bird. Okay, and then let me call this bird. Okay, and let me initialize it here, because this is where the initialization process is supposed to be now. So let me say woodpecker. But who was the person that asked that question, please? Let me check to if you get what I'm saying. Who was the person that asked the question, please?
Yes, I'm following. I get.
Okay. Because wow, we're actually late by 4 minutes. Okay, actually by 4 minutes. Let me take one more question while I try to check out what's wrong. Let me take one more question. Elika Great, could you ask a question, please? Can you ask a question? Hello, I can't hear you. Elika Great. Oh, is it Elike? Sorry, Elike Great. Could you ask a Okay, if to the next person, Moscow Tech, you want to say something? I can't hear Elike Great. Moscow Tech, could you go on? Moscow Tech, could you go on? We'll take that as the last question. Okay, we'll take that as the last question. Anything we can't resolve here? Okay, yeah, please go on, please.
Yeah, I already asked my question. I've lowered my hand.
Oh, okay, we're the one that asked this question. Okay. All right, I'll get back to you. Okay, I'll get back to you later on the Slack workspace. Okay, so once I've checked out what's wrong or anything, I'll get back to you on the Slack workspace. We're already like way past time, and I wasn't keeping track of time. So anything that we've dealt with, okay, please go over it, go over the concept. You are always free to check Google, check out, and you know, where you have confusions or anything, you can always still also reach out to us, okay? So you can reach out to us, and we'll see how to quickly help you. So that'll be that for today. We have grossly, gone way past time. I wasn't keeping track of time. Subsequently, Prosper, please let me know, okay? Just drop a message so I'll be aware of time, okay? Thanks very much for your time. I hope you were able to learn the core concept, okay? I hope you were able to learn the core concept, and as we've seen many times here, these are the challenges you have while going live. You have certain challenges and everything, and sometimes you just need to take a while back to sit and resolve your code issues. No man is an island, so when you are trying to solve your challenges, okay, you are also free to consult documentations. So some of the documentations you can reach out to W3 Schools, NDN, and we'll drop some other links that you can reach out to. You can also reach out to these different sites. So you guys should take out times to go through the materials I've said, okay? And I'm going to be sending also what we have from the code space. So I'll be handing over to Prosper to give closing remarks for today's class.
Yeah, guys, we're already far gone on time, right? So I'll just make this quick. Yeah, so thanks for your time and all. I think this is the concluding class on OOP. So just go over the internet. There are a lot of resources. We'll share some with you too, but then look for some yourself, read, and just try to get a clear grasp of what this whole concept is about. I'd like you to know it's not, they are merely theoretical, but then there are sort of guidelines, right, that helps in the whole coding process. So just familiarize yourself with them, and then just get the concepts clear, and a bit of the implementation. So yeah, you should be fine with that. Yeah, so yeah, thanks for your time.
So thanks for your time. I actually checked and I saw the error I was making. I was calling this.bed instead of this.name. So that's why I was seeing, like, cannot initialize and everything. So just like I mentioned to you guys, they're just like minor code problems or challenges that you will face. I think I was trying to name Woodpecker or something. So I was calling this.bed, and that's why it was showing. So most times your errors, your errors will show you, they will lead you into the solution. So saying cannot access bed before initialization. That was what I was doing before. So I hope you guys will have an exciting moment. I'll see you guys next week. Next week hopes to be even more exciting as we'll be getting closer to like the real deal of coding challenges and errors and lots of implementations. See you guys next week. Please try to do the tasks that will be shared with you ASAP. And I'll see you guys next week. Have a very lovely weekend. Take care, everyone. You are free to exit the class now.